Hello learners, welcome to NIOS Studio. This program is based on Senior Secondary Chemistry course. In the previous video, we have discussed about gaseous state, in which I explained you about various intermolecular interactions, gas laws. In gas laws, we have discussed Boyle's law, Charles' law, Gay-Lussac law, Avogadro's law, kinetic molecular theory of gases, ideal gas equation, and the deviation from the ideal gas. I am Dr. Alka Mehrotra. We will continue lesson 5, the gaseous and liquid state. During this part of program, we will be discussing about liquefaction of the gases. So, I am going to explain the liquefaction of gas with the help of NIOS curves. Now, as you know, the gaseous, the intermolecular space is more and intermolecular force of attraction is lesser in gaseous state. So, how can we liquefy these gases? Then scientists found, and especially NIOS has worked on carbon dioxide. He noticed that gases can be liquefied by increasing pressure and decreasing temperature. The conditions of temperature and pressure under which gases liquefy were first investigated by NIOS in 1869. NIOS found that liquefaction could be brought about at all temperature below 33.1 degrees Celsius or 304.1 Kelvin. But above this temperature, no liquefaction occurred no matter how much pressure was increased. This temperature was therefore called the critical temperature for carbon dioxide. Now, NIOS has taken carbon dioxide and he tried to liquefy that gas, and he plotted a graph between pressure and volume. You can see in the graph that various temperature he has taken, and he plotted the graph between pressure and volume. NIOS experiment investigated the behavior of carbon dioxide and analyze the pressure P versus volume V at different temperature. What he observed, so let's see what was his observation with the help of the graph. Above the temperature of about 48 degrees Celsius, the carbon dioxide resembles that of ideal gas. It means carbon dioxide behaves as a gas if the temperature is above 48 degree, whether it is 50 degree or 51 degrees Celsius. Then he found that as temperature is lowered, the isotherm exhibit distortion which gradually increases. Now, what is the isotherm? Isotherm is the graph where we have the temperature constant, now which is indication of deviation from the ideal gas character. Then he noticed that around 31.4 degrees Celsius, it means when the temperature is decreasing, so the kink is observed which suggests that gas can be liquefied under compression. It means he noticed that carbon dioxide can be compressed only when the temperature is around 31.4 degrees Celsius. Above that, carbon dioxide behave as a gas only. Now, as the temperature is lowered further, the kink spreads into the horizontal line, and that is compression produces liquefaction. It means carbon dioxide can be liquefied at 31.4 degrees Celsius. Now, let's check again this thing and try to understand this. You can see the temperature is 48 degrees Celsius where it is behaving, carbon dioxide behaving as an ideal gas. So, the graph it's showing like a gas. So, 48 degrees Celsius carbon dioxide is like a gas. Now, slowly the temperature is decreased. Again, when the temperature reached around 31.1 degrees Celsius, you can see a little variation, a little kink is seen over there. Now, when the temperature, you can see when the plot is, when the graph was plotted, A to B, it means what exactly is there A to B? It is behaving as a gas. Now, at B, what happens over there? The liquefaction of the gas just starts at B. So the gas condenses at constant pressure from B to C. Now, so that liquid and vapor phase coexist. That is why you can see in the graph that the straight line can be seen from B to C. It means vapor and liquid phases are coexist over there. Okay, now at C, the gas is completely in the liquid phase. You can see again, now again there is going to be change from C to D. C to D, you will find that it is behaving as a liquid. So from C to D, the slope is very steep. Since a liquid is almost incompressible, we cannot compress the liquid. Now how? Why we cannot compress the liquid? Because as you know, from gas to liquid, the molecules are getting little closer to each other. Now when they are little closer to each other, it means it is very difficult for them to compress. So that is why he noticed that this was his observation. So then he said that it's a critical temperature. So critical temperature can be defined as a temperature above which a gas cannot be liquefied. However, high pressure may be applied on the gas. You have seen that above 31.4 degrees Celsius, it was in the gaseous state. So we can say that 31.4 degrees Celsius was a critical temperature for carbon dioxide. Then critical pressure. It is the pressure required to liquefy the gas at critical temperature. It means how much you apply the pressure, gas will not change into the liquid phase. Then critical volume. The volume occupied by 1 mole of gas at critical temperature and critical pressure, these together are called critical constants. So critical constants are very important to liquefy the gases because above that you cannot liquefy the gas. So critical constants are really very important. So these are few critical temperature and critical pressure for different gases. So now let's sum up. A gas can be liquefied. You know what is the liquefaction means? The molecules of gases we know are very far apart. Now if you have to liquefy, definitely we have to come closer. We have to bring the molecule closer to each other. So gas can be liquefied only if it is cooled up to or below its characteristic critical temperature. There exists a continuity of liquid and gaseous state. That is, they are two distinct stages of continuous physical phenomena. So we can say it's the same material, but the states are different. Thank you.